This is Britt Caswell with another example video. In today's video, I'm covering example 3 from section 8-2 in the SavvasRealize Algebra 1 textbook. The goal of today's video is to understand the graph of a quadratic written in vertex form. Alright, so really we are taking all of our knowledge that we've dealt with, or that we've gathered on A, H, and K, and we're talking about how that's going to make the graph look. Alright. So this first part of the question is just asking about H and K. So understand that the vertex of a quadratic lies on the point HK. I'm going to put a little caveat here. It looks like H changes signs. And that's because of the negative that's in the formula. Alright? So remember, H talks about the horizontal translation. K talks about the vertical translation. So if we look at the horizontal and the vertical translations, that'll tell us where our vertex is. Now A has three jobs. All right, if we have a negative A value, you're going to get a vertical reflection. That's what happens when our graph flips upside down. Now if I look for the specific number at A, so I'm looking at the absolute value of A here, if that number is bigger than 1, you're going to encounter what's called a vertical stretch. So it's like the graph is being grabbed at the top and the bottom and pulled away from the x-axis. Now if the number for A, if we're ignoring the sign, is between 0 and 1, you're going to get what's called a vertical compression. All right? That means that we are grabbing the graph at the top and the bottom and squeezing it down closer to the x-axis. So if I look for this triad, let's identify what the parent function, or what the graph is going to look like compared to the parent function. So what I'm actually going to do for this one is I'm going to go ahead and pop that bad boy onto Desmos, and let's look at how it is affected as we graph it. Alright, so the first thing I'm going to graph is the parent function. Alright, that's this red slope. And so now what I'm going to do is I'm just going to start adding key features to that parent function, and I want you to look at what it does. Alright, so the negative for the negative A value flips the graph upside down. The 3 for that A value causes the graph to become more narrow. The -5, which is my H value, moves it 5 units to the right. Now, understand, it feels like it should go to the left, but because of the negative in the formula, that's what makes it go the opposite direction from what you think. And then the +7 moved our graph 7 up on the axis. Now, if you look at that, see the point 5, 7 for my vertex? That's coming from the -5, 7 right there. Alrighty, so if I were to describe the comparison, I would say the graph of f of x has undergone a translation 5 units to the right and 7 units upwards. It has had a vertical reflection and a vertical stretch as well. So there we have it, guys. That is the vertex form of a quadratic. Until next time.